Good morning. I'm excited to be here. As you said, I'm Tim Cortes. I'm the Chief Technology Officer at Plug Power. On behalf of the Plug Power team, happy to be here and today to discuss some exciting things that we're doing and how they integrate into the hydrogen aviation ecosystem. I was really excited to hear the lead-in because I think a lot of what we're talking about doing and a lot of what's going on across the country, not just in aviation, but in a larger hub perspective, I think is very applicable to today's discussions. So with that, I'm not sure how many people actually know about Plug Power. We've been around for 24 years. We'll celebrate our 25th anniversary this June. And for the longest time, we were doing mostly R&D. Commercial scale-up of fuel cells happened pretty rapidly, probably starting more significantly in 2013, 2014. We are headquartered in New York, in the Albany area. To date, we have deployed, though, over 52,000 fuel cell systems. That's mostly in mobility applications and material handling, but also in some smaller scale stationary applications. We have over 2,500 employees, and before the pandemic, we only had about 700. So in the last 2 years, we've grown significantly in terms of our employment base, not only here in the United States, but in other parts of the world. We've done that through just organic growth, but also some acquisitions. We currently use with our customers today at the sites well over 40 tons of liquid hydrogen a day, making us one of the largest users of hydrogen that are out there. And we've done well over 47 million fueling events with our customers at the different sites. So we do consider ourselves a leader both in hydrogen, now going forward with green hydrogen, but also in fuel cell systems. So we started out, as I said, in 2014, really focused on the material handling application. So if you look in the bottom right corner, you'll see a forklift truck. So many of the systems that we have deployed today are in distribution centers. Folks like Walmart, Amazon, Home Depot, large automotives, Stellantis, BMW, they all have, within some of their operations, they've got forklifts, pallet jacks, things that move the material around in their operations. They're powered by hydrogen fuel cells and a refueling infrastructure. So that's how we started, with the fuel cells and the infrastructure. So we've got dispensing capability. I've got a little bit of slide on that coming up. But recently, we've also decided to get further integrated into the hydrogen ecosystem. And I'll talk a little bit about some of the acquisitions that we've done in the last couple of years. But now we're in a position where we're going to be generating, liquefying, and distributing green hydrogen on a much larger scale. And that's going to be through our own acquisitions and the companies that we've acquired and the work and the development that we're doing. So as it relates to aviation, a lot of the work that we've done in the past has now brought us to the point where this application is really, really interesting for us. Not only from a fuel cell perspective, but also from a hydrogen perspective. We start to think about the decarbonization that needs to happen both here and all over the world. Aviation has a place in that decarbonization. So it's really important for us as we look across the applications and the strategy for Plug. Where do we see the applications? Where do we see the need for green hydrogen? And where do we play in those spaces? So with that, we're developing what we're calling a line of ProGen engines. The 125 kilowatt is at the highest power level for this product family right now. We may go higher in the future. But it really is focused on both the larger aviation applications, but also a version of it will be used for probably heavy-duty applications, Class 7, Class 8 trucks. So it's a platform that we think we can build on for multiple applications, but as it relates to the aerospace industry, we're really going to metal plate stacks. We've got some development work going on where we're looking at titanium plates. We've got that design complete. We've got tooling that we have on order, and we expect to deploy those and get those out by the end of this year. But it really allows us to scale and get to the place where we need to be from an energy density standpoint, not only for this application, but for other applications. And it's really positioning us well. I know Arnold is going to be coming up and talking here in a minute, but I did want to mention our partnership that we have with Universal Hydrogen. It's pretty important to us, and it's around a turboprop development that we've got work that we're doing with them. They're working very hard on the actual integration, the actual fueling pods. We're working with them closely on the fuel cell itself. And I think there's some activities that are slated for some flight tests sometime this year, and then commercialization sometime in the 2025 timeframe. And when we look at the partnership, as I mentioned before, we're not just going to be providing the fuel cells. We think there's a great opportunity for us to provide green hydrogen. And when I say green hydrogen, a lot of people throw around colors, and we don't really like to use colors, but just simple definition for us is we're using electrolysis, and we're feeding the electrolyzers with renewable energy, whether it's wind, solar, hydro. So when I speak of green hydrogen, that's what I'm talking about. Lots of people use definitions of carbon intensity. We prefer that as well, but just for the sake of argument and discussion, when we talk about green hydrogen, it's from renewable energies. So we think there's an opportunity with this partnership for us to provide that green hydrogen to this partnership, with really Universal focusing on the integration, the pods, as I mentioned before, the logistics and the ecosystem at the airport for the fueling, as well as the FAA certification activities for the vehicles. And one last show picture here. There was a 30 kilowatt Ironbird test that we did on the left-hand side with them, and also the 1 megawatt platform that they have for testing on the right-hand side that we performed testing with them this past February. And in that particular picture, there's six of our ProGen engines, and we're continuing to progress through the testing with them. We've got some other partnerships I just wanted to mention that we're looking at. Particular Airflow, it's a short takeoff and landing aircraft passenger and cargo application, as well as Heaven Drones. We're doing some work with them on long duration, extended flight times, and heavy lift capabilities. So there's many opportunities, I think, within the aviation sector with respect to the fuel cells and the hydrogen application. When we think about actual hydrogen and its place within this application, there is experience with hydrogen, 40 years in the chemical industrial industry as well as space that we can take advantage of. I think we all understand from an energy content by weight standpoint the benefits that hydrogen has, and the flexibility that it can bring from both a liquid and gaseous perspective. But there still needs to be advances made in the fuel cell application specific in order to get the weight and the densities to where they need to be specific for the application. And we think about some of those other things that are required. How do we think about the actual tanks that hold the hydrogen? The mass of those needs to be reduced significantly. How do we get that down? How do we get more hydrogen into the vehicle? How do we get the higher specific power that I mentioned before? And how do we manage the thermal aspects of the propulsion system? Some of the other things that need to happen is how do we have these quick proof of concepts where we can actually get some flight time and experience, because that's really goes into what's going to happen to certify, from a commercial aviation standpoint when that happens. And then scale up. We mentioned that at the very beginning. Scale is going to be very, very important to be able to support this application as well as others. And we believe that we can actually get the cost of hydrogen, green hydrogen, down to about $1.50 per kilogram. Which we think opens up a lot of markets and a lot of opportunities, not only for this application, but for others. So recently, last year, the president signed some legislation, and within that legislation, there were some interesting things that went into it. So Plug Power and the other members of the FCIA, the Fuel Cell and Hydrogen Energy Association, spent a lot of time and energy working on the wording for the legislation. And there's three items within that legislation that we feel are very, very important. The first is the hydrogen hubs. So there's about $8 billion that have been earmarked for at least 4 regional hydrogen hubs. And they have to be of low carbon. They don't have to all be using renewables, but they have to be of a carbon content that's less than 2 kilograms CO2 equivalent per kilogram of hydrogen generated. But within the hub, it's thinking about how do you tie the generation, the distribution, the storage, and the applications together. And within the New York Northeast area, we're working with NYSERDA, which is the energy R&D arm within the state of New York and other surrounding states, to put together the hub. And we're thinking about across the region, what are the applications and how do we move the hydrogen and how do we store it? Some really interesting applications that you think of are ports. And it's not just seaports, but it's also airports. There's lots of opportunities in maritime for the use of hydrogen and fuel cells, but also at airports. And I'll talk a little bit about the entire airport ecosystem and how that fits in. The second piece is the electrolysis. There's about $1 billion earmarked for research and development and deployment for clean hydrogen production from electrolysis. And then the last piece is manufacturing and recycling. So you think about the full life cycle of some of these elements and some of these systems. How do we invest in the recyclability of those pieces of equipment? And how do we ensure that the domestic supply chain for those materials is strong? So those are really key elements of the legislation. So the overall landscape for the hydrogen hubs themselves, I know this is an eye chart, but there's a lot of people trying to go after the money and after these applications. So up in the top right, you can see in the Northeast, in New York area, there's a group of that have put together an MOU that are working together for a Northeast region. There's one in the Southeast. There's a large contingent in the Texas area, particularly in Houston. They're trying to understand how they can do their energy transition from mostly a fossil-based solution to a cleaner solution. I was in New Mexico a few weeks ago with Universal, and the governor there had put together a roundtable to figure out how can New Mexico, and they've now signed an MOU with Colorado, Utah, and Wyoming, put together a hub for that region so that they can be applicable in terms of the story and the resources that are available in that part of the country that can really be important to this. And then obviously here in California, right, there's a lot of work being done here in California for a hub, but there's a lot going on and there's lots of opportunities. And I think this is really, and $9.5 billion sounds like a lot of money. But in reality, when you think about what it's going to take to scale this hydrogen green economy, it's not really that much. But the important part is getting it going, understanding how these systems work together, how you can generate, how you can distribute, how you can store hydrogen, and then get it to the applications at a cost point that really allows you to scale this. And it makes that system then something where that hydrogen is now more ubiquitous, and it's easily available, and so people don't have to really think about it or worry about where it's going to come from in the future. So for us, in addition to the hydrogen generation that I talked about, we do have the capabilities for, and we do design hydrogen refueling stations. So again, as I mentioned, we've got over 165 fueling stations installed across the country with our customers. And that's small systems, 20 kilograms a day, all the way to about 2 tons a day. And we can get those deployed in a very quick fashion because we've done a design that's modular. It's very simple to deploy, and we can utilize both liquid hydrogen as well as gaseous delivered to the site. And we can also generate hydrogen on site with our electrolyzers. So it's really a significant aspect of getting not only the hydrogen generated but also distributed to the applications that need it the most. So Andy Marsh, our CEO, really believes that this particular application is really important to the decarbonization. He's mentioned it several times, several conferences. He's talked about how important it is, but not just from just a pure aviation application, but also from the entire aviation ecosystem. The ground support equipment, the shuttles that take the passengers from gates to gate. So how do you think about that entire ecosystem? And it's really important. And from his perspective, it's an application in an industry that's really important to Plug. So as I mentioned before, how do you think about decarbonizing the entire operations with green hydrogen? And it really comes down to thinking about all those pieces and those places. And I think that chart that was up before I got up, highlighted some of those. But it's really about how do you build that all together so you can take advantage of the scale, you can take advantage of having hydrogen at the location, and you can utilize it in more than one application. So McKinsey had done a study about the evolving landscape associated with using hydrogen in the aviation sector to decarbonize across the entire operation and the value chain. And they identified two main areas. There was the airport operations, and then there was the actual aviation transport piece. On the left, you can see that the ground support equipment absolutely can use, and I'll show a picture where we've already got fuel cells in ground support equipment at airports. You can definitely use fuel cells in those pieces of equipment, whether it's tuggers, cargo trucks, bag handlers. There's just lots of opportunity to utilize fuel cells and hydrogen there. We talked about the passengers, moving passengers with buses and the internal airport infrastructure. And then on the right-hand side, there's the aviation piece, right? The actual flight equipment. So what we've done is we've highlighted the areas that Plug has been looking at and participating in. Obviously on the smaller and the commuter and the regional prop aspects where you've got hydrogen and fuel cells, those are important to us, as well as on the left-hand side, the material handling equipment. And then, obviously there are others that are going to help from a decarbonization standpoint across the entire landscape. As I mentioned before, from an overall ecosystem, we've got on the bottom left, that's the Albany Airport. FedEx is using fuel cell in some of their tuggers to actually, and our full turnkey solution where we're providing hydrogen, the refueling infrastructure, and the fuel cells for the equipment. And on the right, there's a piece of equipment at the Hamburg Airport that we also have a fuel cell and we're providing hydrogen to. And these are just examples of where zero emissions vehicles, we can get there with green hydrogen, fuel cells, and it doesn't take much today because we've got the equipment, the technology is there, and it's basically low-hanging fruit from an application standpoint. When we think about the cost, I mentioned before $1.50 per kilogram, you have to ask yourself the question, well, how do we get there? And it really comes down to a few things. Scale. Scale drives everything. I think everybody knows that regardless of what industry you're in, typically scale is really, really important. And when you think about scale, that really drives down the cost of the capital. The CapEx, the cost of the equipment itself, as you start to build up the equipment, starts to get driven down. The supply chain gets built up. There's more players, there's more suppliers, there's more competition, and that's really good to drive the cost down. We've also seen a significant decrease in the cost of renewable energy. We've been able to find in many locations across the United States and even Europe where the cost of renewable energy is very, very favorable to be able to use to generate hydrogen. And it continues to go down. And we hope that some of the additional legislation that's coming out, hopefully with Build Back Better, there's there's a production tax credit and an investment tax credit that's in that legislation for hydrogen. And that would also help drive down the cost. And then the cost of capital, getting funding. There's lots of investors now. People really want to invest in green technologies. So we think that the cost of capital is also going to come down. So that's really going to help the main initiatives to drive us to $1.50 or lower for a kilogram of hydrogen. When we think about scale, we're building right now, and I was there last week. We're getting close to finishing that facility, a gigafactory in Rochester, New York, and it's in the western part of the state. And when 2024, when it's fully up and operational, we'll be making over 7 million MEAs, 7 million bipolar plates, over 60,000 fuel cell stacks. We can build over 1 gigawatt of electrolyzer equipment. We're also doing on-site generation, so we're using our own electrolyzers at that site to generate hydrogen. But what it really means is, how do we take this and replicate it in other parts of the country, in other parts of the world? And as part of the hub activities that we talked about, factories and investing in large-scale manufacturing are really going to be important to drive the cost down and get the scale up. Scaling globally, that's also really important. So we've done a lot to scale globally in the recent times. We've done a couple of JVs. We've got a JV with SK in South Korea. We've got a joint venture with Fortescue in Australia. We have one in France with Renault. The JV is called Hyvia, and that's to put together fuel cells and systems for light commercial vehicles, which Renault is very, very good at. And then you think about manufacturing. As I mentioned before, that gigafactory, how do we take that and replicate it? So we've got plans to replicate that in other parts of the world. Again, scale is the thing that's going to be so important to all of us as we build out this economy. So I mentioned before that we've gotten into the green hydrogen space, and we did that back in 2019. We put together our 5-year plan, our 5-year strategy for Plug. And when we did that, we really made the recognition of how important hydrogen had become to Plug. You know, we really wanted to sell fuel cells originally, but hydrogen started to become really important to us and to our customers. And it became important for a few reasons. One, the cost. We needed to be able to drive the cost down. 2, customers had started to ask, how can they take advantage of hydrogen to meet their internal sustainability goals, right? So all these corporations that we're working with are starting to get pretty aggressive sustainability goals, and they want to see how they could take advantage of the fact that they were already using hydrogen, and how could that hydrogen help them in the future. And then just surety of supply. I mean, I think one of the things that had always was always a concern to us is, for us, in the applications that we're in, we had to be at least as reliable as the electrical grid, right? And so what that means is we could never have a situation where we had a customer that didn't have hydrogen at their facilities, that wasn't putting them, in their forklifts and wasn't moving their equipment around. We just could never have any downtime. So surety of supply also became a big concern to us in making sure that the production of hydrogen and the availability of hydrogen and getting it to our customers was at the forefront. So we decided then and there that it was time for us to vertically integrate. And in 2020, because of that plan, we did 2 acquisitions. We acquired a company called Giner ELX for electrolyzer technology, and we also purchased a company called United Hydrogen, and they had a liquefier facility in Tennessee where they were liquefying hydrogen and distributing it. So they also had a logistics system base that they could put together. So really that gave us the building blocks where we could say, now Plug has the capability of generating, we have the ability to liquefy, we have the ability to distribute, and we can distribute whether it's high pressure gas or liquid. And now we also have the fuel cells to help with the end customer solutions. So it really provided an end-to-end product line, which really resonates with a lot of customers, because a lot of them would like to use fuel cells, but they don't know where to start to figure out, well, how do I get a fueling infrastructure? Where do I buy hydrogen from? Who do I get a contract for hydrogen from? They could come to us for one solution. So that's really the piece that we thought was important to vertically integrate, and I think it's really helped the growth of the company even since 2020. I'm going to finish today with this chart that I use in most of my presentations, because I think it's important to note that it's not just private sectors, it's not just R&D, it's not people doing technology labs, and it's not just the government and governmental entities looking at tax incentives and regulations. It really takes everybody working together. And I think over the last 2 or 3 years, I think we've seen a lot of energy and a lot of work put into this hydrogen ecosystem. More so than I think, everybody's been saying for years and years, it's coming, and every few years it's going to be here, and it took longer than anybody really thought. But today I think you're seeing lots of momentum, lots of interest, and I think a lot of people are bought into the fact that hydrogen has to be part of the solution. We say it's important. We don't ever claim that hydrogen is the only solution. There's lots of things that have to be done to get there, and there's things that have to be done in the interim to get there. But we believe hydrogen is pretty important to the country and to the world in terms of decarbonization. So with that, I think probably got to my time, and I think there's probably a few minutes to open it up for questions.